For an amplifier with a single high frequency pole, we're asked which of the following is true. So we have at this pole frequency, the phase of the gain will be plus 45 degrees above the mid-band value. So when we look at this, we're going to be using the high pass STC response. This can be found on page 13 of the notes linked below the like button. Well, we can see here that when we're looking at the phase response, we're going to be looking right here, and that's for this graph to the right. And it increases, our frequency increases at negative 45 degrees per decade, so it's not plus 45 degrees. And our pole frequency would be like right here. You can see it's negative 45. Now we see above the pole frequency, the phase of the gain will increase at plus 45 degrees per decade as frequency increases. This is very similar to the last one, except now we are above the pole frequency, which would be like right here. And so that means now how would we be increasing? Well, it'll be increasing or decreasing at about 0 degrees. So that will not be true. And then we also have none of these, but we'll get to that in a second. So we also have at this pole frequency, the magnitude of the gain will be plus 3B above the mid-band value. And there is a problem with this one, and that is plus 3B. And the problem with this is we flatten out at negative 3 decibels, and so it's not a plus 3 dB. It's a negative 3 dB here. And then we have above this pole frequency the magnitude, so we're going to be looking at this one, of the gain will increase at 20 decibels per decade. So we're going to be looking at this one to the left as frequency increases. And so this is keyword above the pole frequency. Pole frequency being like right here. The magnitude is not going to be increasing at plus dB or 20 dB. Once it's here, it's going to be a constant. And so it's not going to be that one. And so since it's none of these, the answer would be none of these.